So according
স্যার
বলো।
বলছি, আপনিও কি অক্সিজেন সাপ্লাই দিচ্ছেন? আমি আপনার নাম দেখলাম মনে হয় কোথায়।
না 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 না, ওটা ওটা অন্য একজন।
ও আচ্ছা আচ্ছা।
So the thing is that lambda is nothing but h by mv, and this lambda is nothing but de Broglie wavelength, and the associated wave in terms of matter, guide or pilot or de Broglie wave. So de Broglie wave of wavelength is equal to h by mv. Now what you, if E be the, you can say, kinetic energy, say, moving particle, then we know that E equals to mv square, or you can write like that, m square v square by this b square by 2m, where momentum p is equal to nothing but root over 2 me. So if you just place the value of p in place of lambda, so you can write this lambda equals to h by p, so it should be h by, you can say, m p. So you can say that is the one of the formula of zero. And of course you can write that what we know, that according to the kinetic theory of gases, what we know, that average kinetic energy of the material, what we can say, that according kinetic theory of gases, the average kinetic energy of the material particle, of the material particle, that is, E is equals to half of mv square is equals to 3 by 2 kt. So if we of this, so this is h by root over 2 mv that we know. So in E, if we place this 3 by 2 kt, then it should be 3 kt. So this is one, you can say, formula of de Broglie wave. The thing is that, so সো আমাদের কি হতে পারে, এরকম কিছু প্রবলেম আসতে পারে। আদারওয়াইজ আমি কটা প্রবলেম তোমায় করাচ্ছি, যেমন ধরো, it's like that one type of problem that will come, that may, that say the question is given like that, that to calculate the wavelength, we have to calculate the wavelength of thermal neutrons, of thermal neutrons as 27 degrees centigrade, given mass of neutron is 1.67 into 10 to the power minus 27 kg. The Planck constant is 6.6 into 10 to the power minus 34 joule second, and the Boltzmann constant is 1.376 into 10 to the power minus 23 joule per Kelvin. So that is the question. So we know the formula, that is equal to by root of 3 mkt, and from that if we just place the value, because in the particular problem is you should know the formula, otherwise you cannot solve it. 6 into 10 to the power minus 34, and that is nothing but 3 into 1.7 into 10 to the power minus 27, and 1.37 into 10 to the power 23. And the thing is that the temperature is 27, so you have to make it Kelvin, and it is now 300 to the half, and that will give you his answer is 1.2 into 10 to the power minus 10 meter, or you can say that can be written 1.452 Armstrong. That you can say that that is the corresponding answer if you do the problem like that. So the thing is that another type of problem that may be given, that is, you can think of that like that. The questions may come like that, that you have to calculate de Broglie wavelength. You have to calculate the de Broglie wavelength, say of an electron or electron whose energy is, that is the electron you can say that the energy that is given, which is nothing but 50 eV. You know the formula, lambda is equals to h by root over 2m, and that is you can say nothing but, if you put the value, the energy h is, you know, the 6.6 into 10 to the power minus 34, and within the root 2 into mass, that is 9.1 into 10 to the power minus 31, and that is nothing but 50 eV. Electron volt is 1.6 into 10 to the minus 19. If you calculate it, you will get the value. So this is the one type of problem that you need to know. So another type of problem that may be given, that if the questions comes like find, say, the de Broglie wavelength, find the de Broglie of an electron in the, say, first Bohr orbit. In the first Bohr orbit of, if the questions given like that, find the de Broglie wavelength of an electron in the first Bohr orbit. So what you have to find? You have to find the corresponding energy. If you find the energy, you can put it into lambda is equals to h by root over 2me. So we know that energy of the electron in the, you can say, Bohr orbit, energy is En is equals to minus 13.6 by n square e. First Bohr orbit it is given, since it is a first Bohr orbit, so the value of n is 1, and the energy is nothing but minus 13.6 eV, and the de Broglie wavelength is h by root over 2. If you put the magnitude, it will become 3.3 into 10 to the power minus 10 meter. Now there is an important concept to finding the de Broglie wavelength, that is, you just see the problem carefully. That the thing is that if the question comes like that, the question is, say, calculate energy of a proton having de Broglie wavelength, that is given 0.2 meter. So you have to calculate energy of a proton having de Broglie wavelength, that is 0.5 meter. So the thing is that in that particular case, it may be you are thinking that you just put the value and you will get the answer. That means you know that you have to find the energy. That means lambda is equals to h by root over 2 me, and from that you will get the value of energy. But there is a trick. What is the trick? Just listen carefully. That we know that lambda equals to h by, so h by mv. Now if we want to find the velocity v, h by n lambda, and if we just put the value of h is 6.6 into 10 to the power minus 34, mass is 1.6 into 10 to the power minus 27, and this is a femtometer, that means 0.5 into 10 to the power minus 15. The velocity that will be found, that is 8.25 into 10 to the power 8 meter per second, and ironically this velocity is greater than the velocity of light, and of course that is which is greater than the velocity of light, and that will create a problem. That means therefore that cannot be possible, that the velocity that you have to found, the velocity is greater than the velocity of, so therefore we have to consider, therefore it is a relative case, it is a relativistic case. So in case of relativistic case, when we consider, then first we have to find the value of lambda, that is h by p, or you are finding the moment is h by lambda. This is 6.6 into 10 to the power minus 4, and the value of lambda is 0.10 to the power minus 15. If you calculate it, then it comes out is 13.2 into 10 to the power minus 19. That uh, that will come. Now the thing is that, so according to the theory of relativity, that should remember that when that particular case will occur, use the formula of the theory of relativity. So according to the theory of relativity, we know that e squared is equals to p squared plus m naught square c to the power 4. That is the basic formula. Square is equals to p square c square plus m naught square c to the power 4. And the thing is that here e is nothing but, you can say, where we can write that e is, you can say, total energy. E naught can be m naught c square, that is called rest mass energy of the particle. And the thing is that, so if we just put the value that e squared equals to p, we already found is 13.2 into 10 to the power minus 19. So we just put the value 13.2 into 10 to the power minus 19 into 10 to the power 8, that is the velocity of light, that p c whole square plus what is m naught? M naught c square is, you can say, that is the rest mass energy, and m naught is nothing but the mass of that is proton is 1.27, and c square that whole square, c square means 9 into 10 to the power 6, and that is whole square. So it will come out the value of E, this is 14.2 into 10 to the power minus 11 joule. So what we get, that kinetic energy of proton, that is nothing but E minus rest mass energy. If that is the answer of the total energy, but if energy of proton, that should be minus E naught. E is 14.2 into 10 to the power minus 11, and that is 42.2, that is, then that will come out, you can say 27.8 into 10 to the power 11 joule or something. If you calculate it, 71730 MeV, that should be the answer. So